How is everyone doing? Welcome back to another stream of us writing parser rules. Hopefully the last stream that we have to do with parser rules. And there is in fact a viewer waiting. Who could that be? Hello, hello, hello. Tonight, we are going to first, let me quickly set up my chat because apparently it doesn't want to get set up. But is it working? Is it gonna work? There it is. All right. We're good. Let us begin by putting on some music and then just getting right into it again. Velen music, just like last night, and live. How to peg. Hello, hello, hello. All right, so last night we implemented rules to make functions functional. Yeah, they parse now. Right here, you'll see that everything is treated as an expression because, well, a function definition should be considered an expression. And then function calls, invocations, declarations, although I feel like I'm going to actually move these declarations to a more, what would you call it? Say, what was the word for it? A more expressive way to do it. Like, for example, at the beginning, instead of using rules, specific rules for numbers, strings, and what have you, or we could use a type and then a generic let function. I'm wondering if we should make this. I'm really wondering whether we should make it so it has inferring capabilities for types. So you could just never define the type of a variable that you're going to use, and it'd infer based off of the value that you gave it that this variable has this value. I'm really wondering what to do with that. But there is a few things that we need to work on. First of all, and that is fixing the conditionals, because the conditionals are currently not recursive, as far as I know. So I'm just going to write a condition 1 equals 1 as an expression, then and end. You'll see here it is an if body. But what if I wanted to say do this? 2 also plus 2. Now this gets a little bit more complex because if we copy this, thank you, I appreciate that. I would love to see you talk and chat and we can just have fun, because programming does get kind of boring if you're just writing and going through problems without anything to show for it. So it's fun to have company. That's why I stream. How about we do this? But I appreciate it. Thank you. We do this so it can use parentheses here. And then we say it's either a cond expression. And we use the same parsing rule that we defined for... What did we define it for? I forgot. We defined it for expression and term. So that means it either can be a number or another expression. So what I'm hearing is, instead of setting the... What did I do? Oh, yeah, I did this. Instead of putting parentheses around that, I could say, thank you. I could say cond expression here and do that. Could I? No, because it is in fact using an expression syntax right here, because it says expected add, divide, multiply, or power and subtract. That is because the if head that we're using for if body right here, yeah, we're using if body right now, so we don't, how about I use if head? Yeah, okay, let's just make it if head. We're using a condition, and the condition always has to begin with either a string or an expression or an identity. Identifier, sorry. And wait, where does this go? This goes right here, but okay, yeah, that's the comparator. That means it either can be a Boolean because of this. If we say, oh, we haven't defined the Boolean keywords. That is funny. If we say true, how about this? Nope, it's not like I expected it to. Expected equal to or greater than. But that wasn't how it worked. Wait, is it because I put this to make it take precedence? No. Is it because I'm not using if body? What? Oh, it's because I have a malformed string right here. Of course it is. How do I not see that double quote? There we go. This is functional. Now, what if I said I wanted either a cond expr in parentheses or nothing? That means if I took away the parentheses, it would work. Yeah, it would work and it would parse it, but it wouldn't output it. So let's just quickly cut this. Oh, what is the problem? No, it wouldn't work. Of course it wouldn't work because that's not how it functions. We are going to use a condition, and conditions mean this. Can this help make with map customization? I actually thought about making a different program for map customization because maps are a headache. All that this is going to do is going to let you write logic. For example, where could this apply more? Say if you wanted to make Minecraft run on CDDA or make a CDDA clone inside CDDA, this would be the tool that you use if you make it Turing complete, because JSON is basically Turing complete. But for map customization, you would have to have a different program. Excuse me. That works with palettes. And instead of writing those palettes yourself by hand, you'd use the program to write the palettes and pick out the blocks for you, which is going to be an easy program to work with. Easy program to write. Yeah, it is very cool if it can work, if we can get it to work, because we're stuck in the parsing phase. But I will keep that idea in mind. Map customization is also a thing that I'm struggling with. So if we have something that can help with that, that would be very cool. So, say we wanted to do this a 0 or more amount of times. Conditional expression, and it would be followed by here. It is still parsing, which is correct. Thank you. I am in fact going to stream that one as well because it would be cool to actually write something in Rust after so long. I'm just writing parser rules right now. Boolean operations. Or operators, is it? I don't know. Okay, don't judge me for forgetting this. I'm not going to be like Boolean operations. We have not, and, or, and XOR. Is there anything that we don't have? Obviously, we have not as well, but oh. What we have to do is figure out a way to actually do Boolean operators in conditionals. That's a lot more complicated than I originally thought it would be. Shit. What if we just say an optional thing at the beginning of a condition expression is this? It would work, right? Not like that. No, it wouldn't. The rule doesn't compile. The rule doesn't compile. Oh, it's because I forgot the followed by. Obviously, it does still parse, but I wanted to parse in a way that it doesn't silence. Is it because I have to add it as a group instead? Compound symbol or atomic symbol doesn't work, so not. Now a not keyword, not a keyword, more like an operator. It does generate a token because we need it to generate a token. If I add a not at the beginning, it's going to generate a token. If instead of using a rule, I were to just use the text, it would not generate a token because obviously the text matches. Now, if we keep the syntax going with just the conditional expression and silencing that, good. All we have to do afterwards would be, actually, do we have to silence? Because we do have to parse it completely, whether we like it or not. And then bool operation. It is going to be a silent thing that includes and, or, and XOR. Now, what is and, or, XOR going to be? It's the thing that we're all familiar with. 2 ampersands. Then, what was or? Oh, it was this. Yeah, it was the pipe symbol. 1 ampersand. How about it? Let's keep it like that. XOR and Rust. How is XOR working? The bitwise XOR operator is a caret symbol. So what you're telling me with the caret symbol is that it could either mean a power or an XOR. All right, that makes sense. Now that we've done that, we are going to say that this uses a Boolean operator. How is that going to work? Good question. I have no fucking idea. We'll figure it out. What? Did I forget to silence it? I think I might have forgotten to silence it. We want a bool up right here. But we also want a way for it to need parentheses. So how are we going to say it needs a parentheses? We're going to say that it needs to be surrounded by a parentheses thing again. I really wish there was just a way to like operate this with double parentheses being a thing. Because see, it's not going to work if you don't use double parentheses. But if you say 1 equals 1, see, it works. You just have a lot of conditional expressions followed by each other. Oh wait, could I do something? I really wonder if I could just remove the parentheses, because that seems like it's a lot cleaner. Because it does make sense, right? Without parentheses, it still makes sense. And this time we want an or, 2 is equal to 1. And then we just, okay, no, never mind. It wouldn't make sense without the parentheses because we need to figure out the order of all the things that we're doing. If the order of the if statements. Yeah, we're going to say that the cond what? Would that work? Expected expression, ident, or something else. Okay, so what you're telling me is that I can use it like this. No, I can't. That's not how you're supposed to use it, because that's completely wrong. It needs to be recursive. And in order for it to be recursive, we have to make it so, how? All right, let's keep this going. Let's keep this conditional going because this conditional is functional right now. We're going to keep this conditional as is the expression. But for our actual condition, we are going to say that it can be cond body. How about that? And then we'll say that it can optionally have a this and be followed by a conditional expression, just like below, and a Boolean operation plus a conditional expression again for a non-zero amount of times, and it can end in a this if it needs to. And when we do that, we can just say cond body in here, but what we do by doing that is we get this. We get one conditional body. Then we want to add an and. So we're going to add this and we're going to add. That doesn't work. That just doesn't want to work. What's the problem with this? I am very curious. Is it because I need to remove the optionality of this? How about I add the optionality here? Let's make sure our simple parsing functions are functional. Not there. All right. Lesson learned. Don't put optional parentheses there because if you put optional parentheses there, it's going to mess up. No matter how many you put, okay. I think it matches. I think it works. So what we need to do after it is say an and, 1, add, divide, equal, expression, ident, expression. Okay, this works. Now we have a cond body here, but what if we wanted a cond body here as well, and we wanted to say that it expected add, divide, multiply, power, or subtract. I think what's happening here is it's messing up expressions, the expression parsing with parentheses parsing, because it expects expression here. Okay, let's work back on this one by one. What we want for our if head is a keyword. It's a keyword. And then we want to work on a condition. Now, a condition must always begin with this and this. 2 parentheses. Simple. 1 condition. Now, in the condition, you can do a cond body. What's a cond body? You can do not operations or string equals greater than less than 0. Wait, is it because I forgot to inlay the cond body inside the cond body? I'm gonna cry if it's that. I'm gonna cry. All right, let's keep it like that. 1, and then it's a 1, and it could just do this. No, it can't. Because obviously it can't. What do you expect? Fuck. We said it can rerun. Is it because we want to do an OR operation? Yeah, it might be. I'm thinking it is. No, it's not. No, it's not. It can either be a cond expr or a Boolean operator. No. It definitely has to be an expression. This is for logic. Can this be used for It's logical to not run into fire. Hopefully, maybe we can do that because I've lost more than 2 pets to that. I've lost more than 2 pets. One of them was a dermatic in closed space, which was very sad because dermatics take a lot to heal. And the other was a raven that just landed on fire. Like, what do you mean? How does that make any sense to you? Oh my god. We love illogical pets. How do they even pathfind? The pathfinding code is a mess. It expected and expression, ident, or string, or XOR. How did they expect string there? That works? How's your pegging going? The pegging is not going very fun because I'm stumped on the logic. Just lost a dog an hour ago. Yeah, they do pathfind into fire very often. I don't know why. I don't know how. Why is it so attractive to them? I have no idea. We got a condition. Okay. How are you even functioning? Okay, let's work back by using the expert thing. It's either a term, which starts with a number, and then it goes in expression. An expression is either a term, ident, operation, term, ident, operation. That means it includes that inside it, right? I think it does. I think that's what it means. So let me just quickly copy that below so I can copy the whole thing with it. And we are going to bring it here. The way it works is the conditional body and the expression. Then it can either be a conditional expression, like we said right here. Is that why it wasn't working? It might be. We might have gotten this. Never mind, I'm not sure. Let's write this from scratch, shall we? I think we shall, yeah. An expression followed by an operation for a non-zero amount of times. An expression, as is right here, followed by a comparator, which is going to compare it with a string, expression, or an ident for a non-zero amount of time. There's a difference between those. There's a big difference. Operation and term tie back together, but ours doesn't. Ours is behind it. So we're going to say it needs a comparator. Yeah, we're going to say it needs a comparator once. And that should be the expression. Yeah? Yeah. We'll use cond term instead of cond body, so we can just comment this out. And then after it, we are going to write that, just like term, we're either going to say that it involves a conditional expression or it involves a conditional expression in parentheses. I'm losing my mind over here. Does that work? No, it doesn't, because we're supposed to use cond exper here. Wait, but then after we define the conditional expression, then we have to add the ability for it to... What? What? I'm so lost. What if we added at the beginning, like this, which is a cond term at the beginning of everything? But it has a left-facing recursivity, or whatever you call it. Rule could term is left recursive. But how is the above one recursive and it doesn't cause a problem, and ours is recursive? That's a problem. Is it because it's a left recursive, like literally on the left, and it takes precedence on term? It's just recursive. It is just recursive. What? It's not recursive with this one. Somehow, this one can include the conditional, but that one can't. So let's try writing an if statement. It expected add, power, or subtract, but I don't want none of that. That works. All right. Can we add a symbol? No, we can't. What if we add this? It expected... Why do you expect add there? Why are you expecting add there, my good man? My good fellow? Why are you expecting add there? Why is that expecting an expression? I don't want an expression. What happens if I remove this expression matching? It wants a cond exper. What? I'm gonna be honest, writing parser rules for conditionals is one of the worst things ever, because expressions, they use numbers, and the numbers use parentheses. What if we remove anything that uses expression or cond exper? But then if we remove that, it's not even gonna work. So we can't remove it. This is gonna take up a good amount of time, I think, for this stream. Just figuring out how this works. Oh, is it wait, why is it not working? The can't expert. Oh, is it because? Don't even think about. Wait, no, it's not because of that. Wait, but if we don't add that as a thing at the beginning, it will be left recursive. If we add it at the beginning, it's going to be left recursive. If we don't add it, it's not going to function. So how the hell does it work? It's because it depends on a different rule than this one. But expression can either be a term and an ident. Oh my god, what? Sorry, you said you don't understand anything from programming, but I don't even understand anything from programming myself. Like, oh my god, how does this make any sense? Let's rewrite the rule, okay? We're gonna keep it simple. No nots, no whatever. We're gonna just do it like it does up there. And we're gonna say, first of all, either it's a cont term or a string or an expr or an ident, just based off a last rule. And then it's either a comparator or it's a group. And the group is, again, you seem to learn fast. You'd be surprised. It's me just messing around until something works. Ident. Now, the only difference that this had with our expression is our expression could repeat a number of times up for the mathematical expression. But the conditional expression that we wrote seemed to be broken completely. So we're going to define a conditional term now, and we're going to look up at it. The thing that we had is simple, very simple. It's either a parentheses and a conditional expression followed by another parentheses, parentheses, and then it's this. And then it's going to have a left recursive problem. Or it's just not going to work. Oh, it's because I used these instead of those. Okay, fair enough. Yeah, see, it's a left recursive problem. It's going to recurse into itself. What we need is something that's not going to be left recursive. How would we do that? I don't fucking know. Could we just say like shit? Yeah, is it because I forgot to add the conditional body of the thing? Like, it's either a conditional expression or it is this, a conditional expression followed by a Boolean operation, which is followed by a conditional expression. But there is a problem. The rule can't expr is left recursive. You can't use it in itself. Define left recursive for me, please. Because I seem to see this just with recursive rules, and I don't understand why it is the way it is. How is the bitrate looking? The bitrate is very good. Left recursion in this context of computer science refers to a situation in a context-free grammar, PEG. In our case, it's not a context-free grammar, where a non-terminal symbol can directly or indirectly derive a sentential form that begins with itself. Did you understand what that means? Because I didn't. I'm joking, I did. A non-terminal symbol, that means if we go into the PEST documentation, you can see that It is a definition for terminalness right here. Where is it? If I can just bring it up here for you. A non-terminal thing. A terminal is this, a non-terminal is this. And what we have there is a non-terminal symbol can directly or indirectly derive a sentential that begins with itself. So we need to somehow make a rule or a string that isn't gonna match itself. My eyes are glazed over. I completely get what you're saying, to be honest, because mine are also just... I'm losing my mind. I can't. So you're saying that I need a different rule. If it wants to begin with itself, as in a recursion, it has to have something that defines that recursion. Alright, wait, before we do that, let's just disable the problem that we have here. And I'm going to work on an expression. We're going to say this, 1 plus 2 plus 2. Now you see, that's an expression and an expression and an expression. Because all expressions have to begin with something that isn't themselves. Okay, I think I've got what it means. Instead of beginning with something that is itself... Wait. I thought I had it for a second. I didn't. Okay. Not a conned term. My dog's lungs. No. Poor guy. He's going to a better cause. He's contributing to a better cause. It's fine. As long as he lives in your molecular structure or something, I don't know, it's fine. Poor guy. At least it's being useful. If 1 equals 2, then sure, that's a condition with a conned expr. Now we are going to say that what? Oh, say what? Okay. Instead of what? Instead of what, Vivian? Vivian, instead of what? What are you gonna say? Why'd you just forget it? A conned term is a conned expr followed by... How is this working then? Am I just not using the correct thing? What if I add a Boolean operation? No, you expect a divide right there. Or Boolean operation and a What? No, what? This is a comparator for a non-zero amount of time. Now, say non-zero, does that mean I can just keep adding comparator and then... Wow, that is a very big problem. Your new cat, yeah, that's more convenient. That's more convenient. Pet packs are so funny. You just get that guy, squeeze him in there, and he just stays. I love it. I have had the urge to make a mod that fits dogs in a pet pack because pet packs are too tiny. And trying to move dogs around little bit problematic if you don't have like a big ass cage or something, a kennel, if you would. So it's not going to match it more than once. Okay. It's not going to match it more than once. Correct. Understood, sire. If head has a condition, and in that condition there is a cont expression. Wait, what? So you're meaning to tell me that it can match both of them if it wanted to? Okay, what if we say this? It has to be followed by this for a non-zero amount of times. Could I say that technically I wanted an and symbol, ampersand? And after saying pull up, I wanted a string like test equals to test. No, you stupid dumbass. No, how would you ever think that was going to work? How did you ever think that would ever work in a million years, Viv? Of course it's not. A cond term. Is it because I'm doing it like the other way around? Is it because I'm doing it the other way around? I'm not exactly sure. Because a term is just supposed to be something that ties the beginning to the end. Okay. All right. The simple thing that we have to do is that this is a cond term. I'm going to say this is a cond term. Okay? That's a cond term right there. Because this is technically, is it a cond term? Yeah, because if you see in the expression up above, it does an operation. We are using a comparator, basically the same kind of syntax that we were using with a... No, it's not the same syntax. No, it's not. Oh my god, how to parse nested conditionals in a peg. When in doubt, just use Google. Probably has better info than what I can muster up by myself. I could also be evil and go ask AI, but I'm going to use Stack Overflow first. Parsing and validating conditional if in a peg parser. All right, let's read. You already verified I was a human once. Why do you need to do it again? Am I human, actually? I'm starting to have doubts. Because this just repeated itself a third time. I'm definitely starting to have doubts about my own humanity because of my geopolitical situation. Parsing and validating conditional if in a peg parser. Trying to parse a single line conditional if, where code tries to test the left hand is equal to the right hand. If user ID is triple equals ABC 123. How to describe conditional? Peg syntax is very alien. This is the grammar that would consume your example input. Code is a condition or a curly or a statement. And then what is this? A term can be anything. Oh, it's assigning names for it. So when it wants to parse it into JSON, it's going to be able to parse it into JSON. But the main thing that we want to look at here is that code can be repeated. For the condition part, it will produce what? No, I don't think this is going to work because the curly, right here, the code can be a condition, curly, or a statement. A statement is using regex syntax to be anything that includes curly braces and is repeated. Perhaps I did. Maybe I did actually. I've definitely injected too much mutagenic catalyst. I'm no longer human. But I passed as a human and I got into Stack Overflow. I infiltrated them. So the statement, curly, I would assume that this is an or, like a pipe symbol in our own grammar. And the underscore is supposed to continue it. Let's copy this. And a condition that's using the keyword. Okay, I'm going to just take this or all of this. Let's copy all of that code and come here, make a multi-line comment. Is a multi-line comment not supported? Oh my god, you've done it now. Oh no, it is. I just had to do it like a little bit differently. What? Never mind. It's not comments. Block comment. I followed exactly that syntax. Is it because you have to like indent? I just want to block comment. Well, looks like block comments are not going to work for us. So let's abandon the block comments idea and just use good old keyboard to comment everything out by ourselves. I should definitely get some different music. Do I have any good music that's not copyrighted? This is Witcher 3 music, but I need some different. First of all, let's figure this out before I get too distracted. A condition is basically the exact same as our if head rule that we're using. It's using a keyword if, and then it's using these two, and then it's got a dummy then, and the body is a body. Simple enough. Wait. If you go up here, body can be code. Are you telling me that Stack Overflow, my old friend, a curly, that's going to be the code? Oh my god, that is very simple. That's completely garbage. I can't believe I didn't realize this at first. It's using this. It's using a terminal symbol. Well, we wanted non-terminal rules to apply, and we wanted nested conditions to work. It's using terms instead, and terms are the exact same as string, user ID, whatever you have. How to describe conditional statement? If then else using peg. EBNF. How to distinguish AND operator colon from the condition terminal. Hello, Alec. Welcome to the stream. Should you not be asleep by now? Shouldn't you be asleep? A scope body. You need to include a negative look ahead for anything that is not. What? Yeah, that's character AI. I know of that. Used it only once. But it's important. Okay, tell me. Single-lined statement. Without function call support. Nope, this isn't gonna work. This is an Ayatollah Khomeini character. We'll all be damned. We'll all be damned. That's funny. I'll probably check that out later. Maybe we can do it on the stream once for fun. Just started to use peg. WordPress peg. Wait, is that WordPress? And nobody's answered this. Nobody's answered this. Okay. All right. There is definitely one for a lot of them. Maybe Jannati has one. That would be funny. If, then, else, and a block. Okay. Condition equals var or that. And a conditional statement is a conditional equals better solutions. I don't care if your task has better solutions. I want a solution for it. I don't care about any of it. It's using eval. It's using eval inside it. And it's returning something for it. Oh my god. You haven't even defined the difference between them. Terrible solution. Terrible solution. Terrible solution. Hate every second of it. The JavaScript example. Okay, so how does JavaScript syntax work? Online JS interpreter. Why do I need an online JS interpreter? I can just use the built-in dev console in Firefox. Okay, say we had a console. We wanted to say if 1 equals 1, alert, fire. 1 equals 1. Wow, that's absolutely revolutionary, chat. Can you believe it? 1 equals 1. Mr. Heliquidlet. I'm definitely gonna get taken away by the IRGC for talking about him. I mean, enough time has passed for his death, so I don't think anybody cares. If I want to say this and 2 equals 2, does it still say alert? Yes, it does. What if I don't want to parenthesize it? Still says fire. What if I want to do it like this, and then I want to do it like that? But instead of doing that, I want to say, or 1 equals 2, which is going to work. Both of them work, So I think that's good. I think we're fine. But this is the JavaScript grammar based on the grammar from ECMA 262. Non-bitmap characters are completely ignored to avoid surrogate pairing. Using Unicode escape sequences. It's not a valid identifier, but it is accepted by the parser. Strict mode is not recognized. I have no idea what you mean by strict mode. Types to property names. Extract list. Start program. All right. Comment can either be a multi-line comment or not that. Identifier can be this, but I want to get the if. So let's control. Wow, my neck hurts like a bitch. If token is an if. If statement is this. Consequent statement. Test expression. If statement can either be an if token followed by a that or by a that. Alright, thank you. I probably won't have fun figuring out how to do these conditionals, but stay well. I'll see you. Alright, test expression, alternate statement. Now, we have an else token. We have all of those, but what is the syntax behind expression? A statement can be an expression statement. An expression statement can use an expression as an expression, basically. An expression. Yep, you heard that right. Can you believe it? It's an expression. That's insane. Highlight all of them. It's not going to highlight all of them. There is 203 matches, and I don't want to go through all of them. Just match the whole words. And match the case as well. We've got an expression right here. Ahead is an assignment expression. And the tail can be a non-zero amount of expressions. All right. You know what we're doing? We are going to open up a text editor. Do we have any other text editors that aren't currently open? Nope, we don't. All right, first we're going to go back to if statement. It's this. This is our if statement. And we're going to open that up into a new window. Make that smaller. Wordcounter.net, why not? Yeah. And we'll say always above others. So even if we go here, it'll stay here. The Short Timers by Gustav Hasford, 1979. It's a very good novel from what? From the Vietnam War. I would recommend reading it. But all right, let's get to working with this. And if statement is, we're going to write pseudo rule, keyword if, followed by a parentheses, followed by an expression, followed by another parentheses, followed by dummy then, or whatever. Yeah, this is it, our if head rule that we should write. Now, what is an expression, you might be asking? That is what we're going to figure out. We are going to say test not like that. And iteration. Wow, that's a really big parser. That is a really big parser. It has all kinds of things. Okay. All right, property. This is our expression. Our expression is going to be an assignment, or in a snake case, it's going to be an assignment expression followed by what? A group that has a comma and an assignment expression. Are you sure? Yeah, I am pretty sure that I'm sure. Good. We're gonna say that it needs an assignment expression. Then we're going to figure out where the hell an assignment expression even is. An assignment expression needs a left-hand side expression and a right-hand side expression. Wait, but I don't want an assignment expression. I want an if statement expression. Hold on, what have I done? An expression can either be okay. If we say if statement, we're going to be brought here. And then when we were brought here, we had an expression thing. And when we went up to that expression thing, there is only one thing that it can be, which is an assignment expression. There is no other definition for this. You know what? Instead of doubting what's happening, let's trust the process. Let's trust the process and see if we can get to the bottom of this. Assignment expression. How long has it been? Only 1 hour. Okay. An assignment expression. It's right here. An assignment expression is a left LHS expression followed by this and whatever that symbol is. I don't know what that is. Or it could be an assignment operator, as you can see in the rule here. Or it could be a conditional expression, like what we want here. We got to the bottom of it, right? We got to the bottom of it. Instead of using assignment expressions, could we... Because this is going to be a very limited parser, let's be real, I don't care about it that much. We're going to copy the conditional expression. The conditional expression is... Well, there's only 2 places that this is used, so we're getting to the bottom of it. A conditional expression right here equals... Isn't that a ternary? That looks like a ternary operator. But I don't think I want a ternary operator. Logical OR expression has a logical AND expression, and then it has a logical OR operator. What the hell is happening here? Why is it like this? I don't want a ternary, and I'm not running on a ternary. I'm not even doing a ternary. A logical OR expression can either... Oh, there you go. It can either be a ternary or not a ternary. And if we don't want a ternary, we go to a logical OR expression. But isn't that kind of dumb? Only using logical OR expressions? What about a logical AND expression? No, what? Say what now? Say what now? Build a logical expression. So what I'm hearing is that there is a thing called a logical expression as a whole word. Right here, it's writing the parser and code, parser grammar and the code combined, which is not what we want. A conditional expression can be a logical OR expression. Logical OR expressions and logical... Wait, but the head means logical AND expression. What the hell is going on here? I really want to get... I don't think we're going to be finishing the parser tonight, I'm going to be honest. I plan to tell you all about how I'm going to handle dynamic strings and memory allocations on DDA, but I guess that's not happening tonight because we're messing around with this. It's going to have a head of logical and expression, and it's going to be what? Going to have two constituent parts. I think just following this with a non-terminal group of logical OR operator and following this with a logical AND expression for a non-zero amount of times is what we want. And then what's a logical AND expression, you might ask? Good question. A logical AND expression has a bitwise OR expression. What? It would have probably been simpler to do it using brainfuck because then I would have used only stacks. Like, I actually thought about writing a stack-based language, but this is worse than brainfuck. This is the real brainfuck right here. Bitwise OR expression. Am I correct in writing that? Logical OR expression. And then a logical AND expression is a bitwise OR expression, followed by a logical AND operator, followed by a bitwise OR expression for a non-zero amount of times. Or actually a zero or more amount of times. And then a bitwise OR expression is a bitwise XOR expression. It's a bitwise XOR expression. What do you mean? Bitwise OR expression is a bitwise XOR expression. What the fuck? Why is it? What's the difference between the logical and the bitwise? What do you mean? What are you talking about? Bitwise. We are going to simplify this. We are so going to simplify this after we're done. Bitwise XOR expression for zero or more amount of times. Now, bitwise. XOR expression is what? Bitwise AND expression? Oh my god, yes, it was a bitwise AND expression. Followed by a bitwise XOR operator, followed by a bitwise AND expression. Wow! Now bitwise AND expression is finally going to be an equality expression, right? Yes. Good parser. Good parser. Quality expression. Followed by a tail that says, now this tail part, if we do want to separate them, we're going to have to make more rules in order to make it work. From Google, bitwise and operator. I hope your message wasn't blocked or anything. If it contained a link. No, it wasn't. That's good. Okay. Bitwise and operator followed by an equality expression. Right here, non-zero amount of times. Equality expression, I think this is the final part. I really think this is the final part. No, it's not. No, it's not, because it's got to be relational. It's got to be relational. Don't you love that? Really, I almost just wrote fuck there. Expression. Which is, in fact, followed by, again, equality operator, which is pretty simple. Equality operator, right? Followed by a relational expression. Okay. Non-zero or more. I don't know why I keep saying non-zero. What's a shift expression? Dear God. Additive expression. Multiplicative. Exponential. Unary. Exponentiation. Yeah. Exponentiation expression to a unary expression. And then unary expression is a postfix expression. A postfix expression is a left-hand side expression and a postfix operator. Postfix operator is either this, and a left-hand side expression is either a call expression or a new expression. And we just came up here. You know what that means? That means we are basically rewriting our whole definition of what an expression is. Because we are using bitwise, we're using unary, and we're using all kinds of other things. But I think we can skip the postfix operator part. The left-hand side expression, I'm not too sure about that one. Let's search for a call expression. A call expression is either a member expression with an argument and the tail. Okay. That's all there is to it, folks. And a new expression. Good question. What's a new expression? A new expression is a member expression or a new token. What's a new token? There is going to have to be somewhere where it stops. Oh, a new token is something that what? Okay. I didn't want to program anything off stream, but personally I think This whole grammar that we've written up until now, it definitely needs a complete rewrite off stream from me, just so I can figure out what the hell is happening right here. Because as you can see, property names, identifier names, string literal, numeric literal, and then we have parameter list. And there is just so much that I have to learn still. And the grammar we've written so far seems to be fundamentally not supporting what we wanted to do. It fundamentally doesn't support the expressions that we're trying to do. Yeah, it fundamentally doesn't. Now I wonder, a member expression can either have a head and a tail. This is a wholly different style. Cicada, how did cicada handle it? Well, I can easily remember the fact that cicada didn't have complex if statements. It's gone rogue. That's right. It's gone completely rogue, completely out of hand. If statements in cicada, they shouldn't be starting with a dummy, then do new line, etc. And then they did any. What do you mean they did any? And then how did they parse that? Are you shitting me? It says test. And when you go to test, it says it consumes any character in cicada within, by the way, that is not a new line, a then, or a do. That's the whole thing it does. It parses that. You know what? Let's look at the parsers and let's see how it operates on the rule test. We're going to open up locust, and then on locust you'll see that this is the language that it's using. Locust. Locust parse rules, expression, lines. It's going to result in pairs, and it's going to just have tests. It's just going to have tests right here. So I'm going to enable the touchpad because that's easier to work with. Go to parser line. And then what does parse line do? Wow. That's a lot of lines. Okay, you know what? A lot of it is not needed, however, so we're going to just close that part. Let's just not worry about that one. We have an unquote and redirection syntax error. Oh my god! Are you telling me that it uses rules? Tokens to redirection and parse line. Let's rewrite this parse part and make it a separate library. Cyclomatic complexity? I don't even know what those words mean. If tools is arithmetic line, that's a tool, I assume, to see whether that's an arithmetic thing or not. And then it says sub-second. Export brew, homebrew for commands like using semi-OK makes quite dirty here. It's mainly for path completion. Count chars. If line info. So you're telling me that they wrote a very simple type of grammar in pest in the pig grammar that they had. They wrote a very simple grammar there, and instead of using the pest grammar that obviously is very suited to making abstract syntax trees, they went and made their own by parsing a line. Count characters, if has, backslash, if has, that, if, it's all just if statements. It's just all if statements. You know what this reminds me of? You know what this code that they wrote in Cicada reminds me of? Let me go to my own GitHub. Where is it? It is not yesteryear's rewound. There was a tracker conqueror, or not, tracker meta. Yeah. Let me show you this library I wrote a long while back, which has been forked, and there's an issue open for it. Purple and mold, which I haven't worked on. But if you go to the source code right here, single file, almost 400 lines. You come down, there's just let statements, replace, parse, get, replace, and then replace. All of that is just let statements. They didn't do any work in actually parsing the thing into something that they tokenized it, obviously. They tokenized it, and then they got the tokens. But then what do you do with the tokens? You go for token and tokens, separation token, word token, bad redirection, syntax, file descriptor. Then it has patterns. Patterns using regex. Regex. Who cares at this point? Yeah. Wow. Basing our language off of Cicada definitely hurt us a lot in the long run, because Cicada is not a good language. They didn't write proper grammar files that would have been scalable for a language. They wrote drag shit, basically. What I'm learning from this is that we should have written a cascading type of expression. At least that's what I think I'm getting from this. Like over here, it's cascading until one of the expressions finally matches. But how many lines is that? A lot of lines. A lot of lines. Oh my god. Oh my god. Okay, but these are pretty simple and they've been pretty simply put. There's an initializer with an assignment expression, assignment no when. If statement, iteration statement. For token, and then we have all types of other things like continue statement, return statement, with statement, switch statement. Switch token, with token, return token, case block, case clause. Now, obviously, because we're using pest in Rust as our library, we're not going to be able to return like they are returning here. Pest takes care of doing that for us automatically. But it is still like a lot of lines. Source element can be a statement or a function declaration. And a program. What's a program? Program can be a list of source elements. And source elements can be a list of source element. No, it can be source element followed by a source element, if they so desire. And I would just want to remind you that this can parse this language. Like, you see all of that code that's written here? This code contains all the definition to parse itself. Isn't that insane? I think that's pretty cool. But this, and the way that they've cascaded everything, whatever this is, who let you write? Who let you write a grammar? And why did I base my grammar off of your grammar? I am appalled by myself and my actions. Function body can be source elements. So as you can see, this is recursive. It just has a body, and then it has an expression, it has an identifier, it has a few basic stuff at the top, and everything else is with just everything else. Unicode connector punctuation. How cool is that? And then if you go really up, you will see that war types, property to names, call expression, member expression is an object. Okay. Build a reduce. It has a reduce function. And as you can see, this is contained within a block. It's within a block. So this is not actually part of the grammar. The grammar begins here. It's sectioned off to lexical stuff. And then as you get down... What? Okay. As you get down, this is still just lexical stuff, regular expression, Unicode characters. Wow. Tokens, skipped, in the file. Number conversions, irrelevant. This is the actual part that's going to be important in our code because it has an array literal element list. Elision? What is an elision? Okay. Property assignment. This is the same thing as Lua, by the way. If I bring up the Lua cheat sheet and go down, you can see that syntactic sugar, these are equivalent. So if you want to assign to the property, you could either use this or this. Doesn't really matter. I hate the fact that I have to redesign this from the ground up. And I'm going to be honest, right here, 2 a.m. Not the time to redesign the whole grammar from the ground up and try to understand what's going on at all. But I am happy because this makes a lot more sense. We have an actual defined left-hand side, and this is something that I overlooked in our original grammar. If you come over here, we don't have a defined left-hand side. Everything that you see here is a mishmash of whatever we just put together. We don't have anything actually strictly defined to be the left-hand side, and then the right-hand side is the thing that expands. And remember, you have to have a left-hand side. If you don't, it's a bit messed up. Left recursion, just like we learned today, left recursion is going to happen if we don't have a defined left-hand side and separate it from our right-hand side. Call expression, and these are all kinds of the operators that we want, and all the expressions that we want with the operators, but I don't get what the other type meant. A block is just a simple thing, it's a block. I don't think our language is going to be very similar to Lua, but I'll try to make it similar to Lua. I really like this syntax. This block syntax right here, you see that? This syntax for block syntax is implicit. In Lua, it's implicitly defined that it is a block. But I like this syntax better. This is also the same syntax that we use in Rust. So I'm going to work with that instead. Empty statement. If it's a semicolon, it's an empty statement. How beautiful. How clean. How lovely. An initializer. As long as it's not that or that. Variable declaration. No init variable declaration. That means if there's an identifier and then init, it's an initializer, no in, which is an assignment expression, no in. And the if statement, which was the one that we wanted to work, but because they cascaded this grammar as a whole, they don't have to worry about left recursion or anything. Well, we do have to worry about left recursion. This in turn generates the cleanest abstract syntax tree that you can ever imagine. This will make the cleanest abstract syntax tree ever. Yeah, a slight change in what we want it to do. It's no longer Lua. It's probably going to be JavaScript because as much as I hate JavaScript as a backend developer, the syntax is way better than Lua. I'm going to be completely honest. Alright, well, it is 2 a.m. So, and I am just absolutely demotivated by this whole development that has occurred. So, I'm going to close that. This is fine. This whole grammar that we wrote, by the next stream, which is probably tomorrow, this grammar will be rewritten from the ground up. And this time, as soon as the stream starts, I'm going to show you pseudocode and I'm going to walk you through how it works. And hopefully it'll give you a clearer image than the image we got today, because it was very opaque. What happened today was extremely opaque, but we will never despair. Don't worry about it. We are going to work through this. The good news is that as soon as we work through this, we can actually move on to the fun parts. But yeah, see you all tomorrow. Thanks for tuning in. I appreciate it a lot. And I'm sorry that much didn't happen in this stream other than being confused. By the next stream, we're actually going to do real work, because this stream was terrible. I will fix it. Bye, everyone. Good night. Good night.